So now we're going to have a look at I/O ports. In the 8051 microcontroller, you have three major ports, the P0, P1, P2, P3. Each port has within it 8-bit inputs. So that is the 0th, that is the 7th. So you can take 8 bit values from each port, or you could access each individual port like P0.2, P1.4, however you wish to. So there's usually not much theory that is asked from this part. They usually just directly skip to the programs. But we look at some basic theory. There are some important points for you to know. For instance, in port 0, there is a dual role which it plays. So if you noticed in the diagram, you must have noticed that in the port 0, they have the pins marked as AD0 to AD7, which means these are pins which can be used for transmission of address and data. Now there's another pin which is called the ALE pin. You can either set bit it or clear it. This pin number 30. So now depending on how you set it, you can define if it is going to be if it contains address or if it has data. If it's 0, it provides data. If it's 1, it has address and data. Now they won't ask you any questions based on the structure exactly. Since cat is right around the corner, I will skip over most of the theory because you will not have any theory on this. I'll just mention one more thing about port 3. Port 3 is another very important, because port 3 is where you're going to have your interrupt controls from. So mainly these two and also these two. So when we look at interrupts later on, you'll understand the importance of it. But for now, just make note that port 3 is where your external interrupts and internal interrupts are linked. So you do not need to know the logical structure. Again, later on, if I do find time, it's very simple. It's basically just flip-flops. I'll explain it. But for now, let's have a look at some programs. So one thing in the microcontroller is, if you want to define any port as an input port, the value of that port needs to be set as 1. Similarly, if you want to define it as an output port, the value of the port needs to be set as 0. Now, how do you remember if it needs to be an input port or an output port? If it's an input port, just write 1. 1 looks like a rod, I looks like a rod, input. Similarly, O, it looks like an egg, the letter 0 looks like an egg, output. A lot of people used to get confused with that. You just can use this to remember it. However, you'll notice that later on when you look at more programs, you will realize that you do not need to define it as an input port or an output port all the time. If you have a very strict teacher, then just to be on the safe side, define it as an input or an output port, and then obviously comment and write what you're doing over there. But yeah, let's look at this question. So port 0 is configured first as an input port. So how are we doing that? We are writing the value 1111 to the register A and then moving that to port 0, which is essentially making all the values of port 0 from P0.0 all the way to P0.7 as 1. Now, if I'm making it 1, what am I doing? I'm making it as an input port. Now, once that is done, let's see what the question asks next. Then the data is received from that port, which makes sense, right? Since it's an input port, data can be received from it. If the question says that data is transmitted from some port, that means you have to make that port as port 0. And then it is sent to P1. Now over here, if data is being sent to P1, it's being received from P0 and sent to P1, which means P1 is going to be an output port. So let's look at the code. You can see over here, you're writing move P0, comma A, which means you're getting the data from P0 to A, and then from A, you're moving the data to P1. Now here you must have noticed that they did not define port 1 as an output port. So that's what I meant, that sometimes they won't, in all programs, you do not have to define it as an input or an output port. You can just ignore it. However, if your teacher is strict, just mention it. In practicals, if you're given the Atmel 8051 kit, you still don't have to define it. It works perfectly fine with Keel. But yes, one function to note here is sjump. Sjump short stands for short jump. Let me just write it there. Short jump. And when you write sjump back or sjump followed by anything, essentially what you're saying is after whenever the code whenever the microcontroller is executing the code, it's going to execute that line, then execute that line, then it's going to come here and see that you said short jump back. Which what that means is within that org, you're going to write org000h, right? You're telling the microcontroller that within that org, there is some address, there is a house which has a name called back. So now the microcontroller is going to look for the place, for the building which has the name back. Once it finds it, it's going to go there and start executing from there again. So now what you must realize that what we're doing here is essentially creating an indefinite loop. So it's going to do this line, then come here, go there, and again, just keep going over and over again. Let's look at another question. The following code will continuously send out to port 1 the alternating value of 55H and AAH. So essentially, this is going to be the output which we obtain at port 1. Alternating values of 55H and AAH. So let's look at the code. Now here you must have noticed that here port 1 is going to be an output port, right? Because you're sending out to port 1. But nobody over here has defined port 1 as an output port. One way you can define a port as an input port or an output port is either by doing clear or set bit. Clear makes all the bits of that corresponding port 0. So if I write clear P1, it's going to make all the pins of P1, that is P1.0 all the way to P1.7 as 0. If I write set bit P1, what this is going to do is it's going to make all the pins of P1 as 1, hence defining it as an input. But over here you must have noticed they didn't do that, but that's all right. So first of all, we are writing the value 55H into A. We have to alternate between 55H and AH. So we're going to start off by 55H. We write 55H into A. Then from A, we write it to P1. Now there's an ACALL delay. What is ACALL? ACALL, I think, stands for absolute call. Now, when you write ACALL delay, if you remember how I mentioned over here that when the microcontroller sees sjump, it's looking for the building which has the name back. Similarly, when I say ACALL, within that org, the microcontroller is looking for a building which has the name delay. Now over here, the code is incorrect or incomplete, I would say, because they haven't defined the delay function. So now let's define the delay function over here. Now basically what you're trying to do is generate a square wave. This delay function is something which is just going to be executing so that the value which is being pushed out from port 1 is held for some amount of time so that you can get that flat part of the square wave. So suppose I switch to AAH. Once I switch to AAH, I want to hold that value for some time and then flip again and then hold that value for hold the 55H value for some time. So this holding time is usually what is handled by a delay function. We will look at this in depth when we go into timers, but for now let's write a simple delay function. We can use the register R1. By the way, there's R1 to R7, sorry, R0 to R7, which are registers where you can store 8-bit values. So we will write move R1 comma hash 255 or anything basically, hash 55H, let's just do that, or hash any value, basically any value. And once we move that, we will write djnzr1 delay and then sjump to back. Or actually, wait, no, this will not require an S jump, my bad. So how does this work exactly? So whatever value you move into R1, let's assume you moved the value of decimal 100. Now decrement jump if not 0 R1. What you're going to do is decrement the value of R1. So once you decrement it, what is it going to be? 99. Now, is this value 0? No, this value is not 0. So, oh wait, here, let's try this here. Hold on for 1 second, I'm really sorry, but yeah. Suppose you write it like this. So, now, dj and z R1 here. So you're going to decrement the value of R1 and check if it's 0. Is it 0? No. So you're going to jump where? Here. So basically dj and z, that is the decrement jump if not 0, creates an infinite loop till the value of R1 becomes 0. When it becomes 0, you're going to jump back to the next line. That's how it works. So you're going to stay in this loop over and over again. If anybody has, and this can be a bit confusing to some people, if anybody has any questions, there's going to be an email ID in the caption which you can drop a mail to, and I'll be happy to help you out. But yeah, you're going to you're going to stick in this infinite loop till the value of R1 hits 0. Once it hits 0, you go and you can continue executing your program. Now, while this is happening, at P1, nothing is going to be happening. So the value of 55H is going to be maintained at P1. Now that value is going to be maintained, and that's how you get your square wave. Similarly, once the delay is done, AAH is going to be loaded. It's going to be short out, so it's going to come there. Again, you're calling the delay. While this is running, this is going to just hold that value over there like that, and then you keep doing this infinitely. Let's have another look at some more codes. So here we are going to be writing the code in a bit more efficient way. So you want to be accessing the port directly without going through the accumulator. Okay, yeah. By the way, over here you can see that we are writing the value into the accumulator, and then from there we're writing into P1. You don't have to do that always. You can directly write a value into the port. What you can't do is write the value from one port to another directly. You have to write it from one port to a register or the accumulator. Then from there you can move it to the next port. Suppose I want to send from P1 to P2. From P1 I'll have to write it into A, and then from A into P2. Let's look at another code. Similar question to what we saw earlier. 50% duty cycle. 50% duty cycle means the on time should be 50% of the total time period, which basically means the off time is going to be 50% as well. Suppose I say 25% duty cycle. That means the on time needs to be 25% of the total time period, which means the off time will have to be 75%. So let's look at this question. 50% duty cycle on bit 0 of port 1. Bit 0 of port 1, which basically means P1.0. Now, over here, once again, they haven't defined port 1 as an output port. That's why, because you can see they're directly starting from this function. So set bit P1, basically what you're doing is you're making it setting the bit. Then lcall delay. Lcall is long call. Now, if you remember what absolute call was, which is something I just said, in absolute call, you tell the microcontroller that within that ORG itself. Okay, think of ORG as a block of a gated community. So think of a gated community with multiple blocks. A block, B block, C block. Or like think of this as the campus. Now, when I say A call, or when I say S jump, A call and S jump are going to cause the microcontroller to look for, suppose I write, suppose there's multiple rooms in A block. Suppose I say A call 1301. So now what the microcontroller is going to do is within the hostel block A, it is going to look for the room number 1301. Similarly, if I write sjump 1301, the microcontroller is going to jump to the room number 1301. Suppose I write lcall 1301b. Now, when you write lcall, which is long call, what the microcontroller can do is, instead of looking at A block itself, it will look at B block or C block, wherever you have defined room number 1301, assuming that 1301 is only there in one of the two blocks. That's why stands for long call. You're not looking within your own block, you're going a longer distance to another block to find it. Similarly, if you have ljump, which is long jump, again, long is the keyword over here. So in this program, what they're presumably doing is they're defining the delay function in a different org. So this org, suppose you're writing this part of the code in org00h. I could be writing the lcall delay function in org 0030h, and I could write my delay function there. That basically, I'm not writing it in this hostel block, I'm writing it in another hostel block. So yeah, let's have a look at the code. First of all, set bit P1, you're setting the value of P1 to be 1, lcall delay. While the delay is happening, the value of P1 is going to be held. Clear P1, you're making P1 0. Lcall delay, again, that value is going to be held. And sjump here. It just keeps looping over and over again to give you the square wave. Let's have a look at another question. This is a question which can come. Keep monitoring bit P1.2 until it becomes high. When P1.2 becomes high, write the value 45H to port 0. Alright, so you're going to monitor P1.2 bit until it becomes high. If I'm going to monitor P1.2 bit, which I can say that I'm expecting some sort of change to be inputted at P1.2. So if I'm expecting an input at P1.2, P1.2 is going to be my input, hence I will set bit. When P1.2 becomes high, write the value 45H to port 0. If you want, you can define port 0 as my output port, and I could write clear port 0 over here, but they haven't done that, and that's fine. So yeah, let's have a look at the rest of the code. Then I need to send a high to low pulse to P2.3. So first that, then that. All right. First of all, make P1.2 as an input port. Store 45H in the accumulator. Now, J and B stands for jump if no bit. Basically, if there is no bit as in no bit translates to 0. If there is a bit, that value is 1. If it is no bit, it's going to be 0. So jump if no bit 0 again. Basically, you're going to check if P1.2 has the value 0 or 1. If it is 0, you will jump to again, which is over here. So essentially, this is polling. You're polling over and over again, checking continuously to see if the value of P1.2 has become 1. The moment, why are you doing that? Because you want to know when it becomes high. So instead of writing jump if no bit P1.2 again, I could also write, if this again was not there, I could write again over here, and I could write jump if bit P1, JB jump if bit, means if P1.2 has a bit, which means if P1.2 is set to 1, jump to again. But since this is not what they've given in the code, we'll just go by what they've given in the code. J and B P1.2 again, you're going to continuously check if P1.2 has the value 1. The moment it does have a value 1, you will not jump to again, you will go to the next line because, well, jump if no bit. If it does have a bit, keep going to the next line. We're going to go to the next line and move A to P0. Yes, that's what we want. Write value 45H to port 0. Then send a high to low pulse, high to low. So set bit, clear bit, high to low. That's another program. Let's have a look at another one. Assume that P2.3 is an input port. So you can write set bit P2.3. But oh wait, they've said assume it, so you don't have to write that, never mind. and it represents the condition of an oven. If it goes high, that means if P2.3 becomes 1. So again, we're going to use the JNB, we're again going to be using the JNB function. It means that the oven is hot. Monitor the bit continuously. Again, so yeah, we're going to write, will be something like here. We're going to monitor this bit continuously. Jump if no bit. No bit, which means it's 0. If there is no bit, jump to here, which is here. So you're going to continuously keep doing this. If there is a bit, you will not jump to here, you'll go to the next line. So whenever it goes high, send a high to low pulse to port P1.5 to turn on the buzzer. Simple. The moment you got the moment it became 1, high to low pulse, set bit high, clear bit low, and then again keep monitoring and run the loop indefinitely. This is a very important question, and so you won't get these questions directly. Obviously, they will implement this question with something else, like if switch is 0, then instead of send the letter N to P2, you could be asked to print the letter N on the LCD, anything along those lines. But let's have a look at this code. Switch is connected to P1.7. If switch is connected to P1.7, what does that mean? P1.7 is a place where I'm expecting to receive an input because of the switch. Hence, P1.7 is going to be an input port. Write a program to check the status of this SW means switch and perform the following. If switch is 0, send the letter N to P2. If switch is 1, send the letter Y to P2. Use the carry flag to check the switch status. All right. Let's have a look at the code. Set bit P1.7, make it an input port, right? Now, move C P1.2. Basically, what you're going to do is, whatever value is there at P1.2, you're going to move it into the carry flag. Jump if carry. Jump if carry. Now, what is carry? Carry is the carry flag. What is the carry flag? C. Where does C get its value? P1.2. So, whatever value is there in P1.2 is going to be in C, which is going to be my carry flag, which is going to define the functioning of the jump if carry, which means if my bit is 1, I will jump to what address? Over. So, we'll jump to over. If it is not, you're going to stay there. You're just going to continuously keep monitoring. If it's not, you will go to the next line. Now, you have to pay attention over here. Jump if carry, which means if the value of P1.7 is 1, I'm going to another place. Now, when is the value of P1.7 going to be 1? When the switch value is 1. If the switch value is 1, I need to send the letter Y. So, if my P1.7 is 1, I will go to over. Once I get to over, I need to write a code over here, which is going to send the letter Y to P2. So you're going to move P2 comma hash Y, S jump again, to repeat the process again. In case my switch is 0, then I need to send the letter N to P2. So what will I do? This JC line brought me over here. But that is jump if carry. If no carry, it is going to go to the next line. It will not do the polling thing. It will just simply move on to the next line. And in the next line, I will move P2 to N, S jump again. This is a common line because you're going to continue. You want to run this continuously, right? So you'll come back there. Again, you'll write the value of P1 into C. Again, you're going to just jump if carry, and you just keep doing that indefinitely. This is the last IO ports programming question. A switch is connected to P1.0. What does that mean? P1.0 is my input port, and an LED to P2.7, which means my P2.7 is an output port, because LED is an output device, right? LED is not an input device. Write a program to get the status of the switch, okay, and send it to the LED. Basically, whatever bit is being inputted at P1.0, same thing needs to be output at P2.7. Simple enough. Set bit P1.7, make it an input port. Now, this is something which they've done. They've done it again using the carry flag, but you can do it using the accumulator or any register you want. Now, move the value of P1.0, that is of the switch, into the carry flag. Then whatever that value is, send it to P2.7. Why? Because you can't directly send. You must ask, you could be wondering, why am I not writing move P2.7 comma P1.0? Why? Because you cannot directly write from one port to another port. So yeah, you're just using the carry flag since it's a single bit, and you just S jump again and keep doing it indefinitely. So that's it for IO ports. Next video we'll be looking at timers and